Good morning, ladies and gentlemen. Today we are going to find roots from a graph. This is chapter 13, section 3. Roots are actually just another name for the solutions. When you factor a quadratic, make your t-chart and solve both sides of that t, getting two answers. Those solutions are also called roots. They're synonyms. They mean the same thing. Take a look at problem 1 here. Find the roots of the quadratic by factoring. What we're going to do is we'll rewrite the equation setting it equal to 0 instead of y. We want to know when this is equal to 0. We'll do our puzzle. Factors of AC, which add to be b. We want two things to multiply to be 10 and add to be negative 7. That's negative 5 and negative 2. So we're going to rewrite the problem. X squared minus 5x minus 2x plus 10 is equal to 0. We'll factor the first two terms as an x is the greatest common factor. The last two terms, negative 2 is the greatest common factor. And then what do both of these terms have in common? I'll give you a hint. The term is inside parentheses. Take the x minus 5 out, and the coefficients are what is left. And you have that. At this point in time, we go to a t-chart. X minus 5 is equal to 0. We'll add 5 to both sides. X equals 5 is one of our solutions. X minus 2 is equal to 0. We'll add 2 to both sides. We get x equals 2. That is our other solution. These are also called roots. They are also called roots. Well, roots can be found graphically. So what we're going to do now is we're going to graph the same thing. And we're going to look for this x equals 5 and x equals 2 and see if we can find it in the picture. So we'll scroll down here to our graph. X squared minus 7x plus 10. So the same equation. In order to graph this thing, I'm going to have to figure out the axis of symmetry. Well, a equals 1, b equals negative 7, and c equals 10. You have a quiz on graphing quadratics tomorrow. This is a great example of a quiz question that you could have. X equals negative b over 2a is the equation of the axis of symmetry. It also gives me the middle x value for my table of values. So let's see, negative 7 over 2 times 1 is 7 over 2, or 3.5. So x equals 3.5 is our axis of symmetry. And it's interesting. It's the first time we've had a fraction, or a decimal in this case, for our turning point, or our axis of symmetry. 3.5 goes in the middle of our table. The closest integer to 3.5 smaller than 3.5 is 3. I'm going to go up to 2 and 1. Closest integer to 3.5 but larger than 3.5 is 4, 5, and 6. Notice I'm not going to fill my table with decimals. We're just really creating some grief for ourselves doing that. There's better points to plot, and those are the integers that are 3 above and 3 below the value you get from the axis of symmetry formula. So I've typed x squared minus 7x plus 10 into my graphing calculator. I hit zoom standard just to make sure I wasn't doing one of those word problems, and my windows are all messed up. There's the picture of it. You notice it does have a turning point even though there's a fraction involved. Second in table. Here is my table. I can drag it over so you don't have to watch me flip back and forth a bunch of times. I got 1, 4. I got 2, 0. 3, negative 2. 4, negative 2. 5, 0, and 6, 4. And our table does not include what y is equal to when x is 3.5. So I'm going to show you a new calculator function now. Here's how we do it. You hit second, and then you want the trace key. Now the trace is a gray key, but if you look above it, the word calc, C-A-L-C, is in blue. So really we're hitting second calc here. The first choice in the list is value. This lets you plug in your own value for x, and it returns to you the y value. So 3.5 goes in for x. Y is equal to negative 2.25. Negative 2.25. Let's graph this thing. We have the point 1, 4, 2, 0, 3, negative 2, 3.5, negative 2.25, which is going to go right around there, 4, negative 2, 5, 0, and 6, 4. So here we go. Got to be really careful. All those points are nice and close together. We want a beautiful graph. They did not give us values to graph between, so we are going to put arrows on the end of our graph. We have to label these points. It gets really messy, I know, but we want you to get full credit on your quiz. So we need to get into the habit of writing them down, even though maybe it's not the most enjoyable thing to have to do that, especially when we got to squeeze them all in here. So we've got 3, negative 2.25. We have 4, negative 2, 5, 0, and we have 6, 4. Last thing I'll do here is put the equation on here, and it is graphed for full credit, although what I didn't do was take a look at my table, or I'm sorry, my axes, which have to have arrows on them, and X and Y is already labeled. Alright, so what does this have to do with roots? Well, if you take a look at the problem up above, I'm going to scroll up for a second. You notice x equals 5 and x equals 2 was the solution to that equation. So x equals 5 and x equals 2. Well, look at what you have here in your table. X equals 5, x equals 2, and in both cases y is equal to 0. If you take a look, once again, scrolling back up to the original graph, what was the first thing that I did when I rewrote the equation here? It was y equals x squared minus 7x plus 10, and now it's 0 equals x squared minus 7x plus 10. I changed y to be 0. Y equals 0 is the equation of the x-axis. So what you've got here is when the equation crosses the x-axis, this is actually the solution that you're going to get when you factor and solve this. Those points are the roots. These points from your table are the roots. So depending on whether or not you have to graph it, the table can tell you the roots, the drawing can definitely tell you the roots. Those are the roots of the quadratic. So we have a couple of examples here. We're only going to do one of these examples. Maybe we'll pop down here and do Roman numeral 3 because it has a couple of different twists to it. Or at least it has the nice answers explained. Alright, 1a, we're going to graph it. So negative x squared plus 3x minus 2. A is negative 1, b is 3, c is negative 2, x equals negative b over 2a is the axis of symmetry formula. This is negative 3 over 2 times negative 1, which is 3 halves, or 1.5. So x equals 1.5 is the equation of the axis of symmetry. So when I make my table, 1.5 goes in the middle. Smaller than 1.5 is 1, 0, and negative 1. Bigger than 1.5 is 2, 3, and 4. I'm going to go to my calculator now. I am going to hit y equals and clear out this last graph. I have negative x squared minus 3x. Let me check it again. Nope, plus 3x. Plus 3x. Plus 3x minus 2. Take a quick gander at the picture. Negative a makes it a sad face, so that's no surprise it's upside down. We're going to hit second in table, and we're going to have to get these values in here. Now we need to go to negative 1, so I'm going to scroll up a little bit, drag this over just for the ease of use. Negative 1 gives me negative 6, 0 is negative 2, 1 is 0, 2 is 0, 3 is negative 2, 4 is negative 6. I go back to the calculator, I hit second calc, value, and I want to know what y is when x is 1.5. When x is 1.5, y is 0.25. That's 1/4, but 0.25 will suffice. Now I go to my graph. I'm going to plot these points. A does say to graph this thing. So negative 1, negative 6. 1, 2, 3, 4, 5, 6. 0, negative 2. 1, 0. 1.5, 2.5 is going to be like right there. 2, 0. 3, negative 2. And 4, negative 6. So when I graph this thing, come down, draw arrows, come down, draw arrows, and I can label the points, which I'll do in black. No reason, just want the graph itself to stand out. Okay, our last point there is -1, -6. And finally, I would have to write the equation on here. Y is equal to -x squared plus 3x minus 2. Put arrows on your axis. Label the x and y axis, which has been done already. Okay, so there we go. So, roots, says B, find elements of the solution set. Well, once again, there's two places you can find it. You can take a look at where y is equal to 0 in your table of values. You can take a look at the 2 points where the equation crosses the x-axis, and that is when x is 1 and 2. When x is 1 and 2. Alright? Done. It's done. Part C, however, wants us to factor the quadratic. So -x squared plus 3x minus 2. I'm going to copy it down here. -x squared plus 3x minus 2 is equal to 0. We'll make our puzzle. AC is going to be positive 2, B is -3. 2 and 1 are factors that multiply to be 2, add to be 3. So -x squared plus 2x plus x, or 1x I guess, minus 2. So what am I going to do here? I'm going to factor -x out of this. I get x minus 2. Here I'm going to factor just a 1 out. I get x minus 2. And let me pull that up a little bit. I need the room. There you go. And then I take a look at what they have in common. They have an x minus 2 in common, and that's -x plus 1 left over. That's equal to 0. When I make my t-chart, I have x minus 2 is 0. Add 2. X is 2. And I have -x plus 1 is equal to 0. Subtract 1. I get -x is equal to -1. I'm going to multiply both sides by -1 to change the sign. X equals 1. So once again, we have an algebraic solution, which is done in blue down here at the bottom. We have a graphical solution. The table's in blue. Obviously, the graph is orange, and the points are all labeled in black. So two ways to do the problem. Now we have another example here, but once again, I don't want to tie you up too much. It's the same thing. Basically, we're talking about how the graph can be used to find the roots as well as factoring. Okay, so we're going to work on some problems in class tomorrow. I look forward to seeing you, and please remember your review book money. Test on Friday. Test on Friday on Chapter 13.